we have discussed about the electron gain enthalpy, right? Okay. So yesterday,
So once can you revise, sir?
electron gain enthalpy means what we can say when the amount of energy released. Okay.
Yes, sir.
Mm. Amount of energy released when one electron is added to an atom, right? So that only we
Yes.
are saying that electron gain enthalpy we can say. So now from that one, and from that one electron gain enthalpy, how it is changes in periods and how it is changes in groups and what are the parameters which affect the electron gain enthalpy, those points we have discussed already, isn't it? Mm. Now see, under this next point is as the size in from left to right, what will happen? So the electron gain enthalpy will become more and more negative, and from top to bottom, electron gain enthalpy will become less and negative. And how atomic size will affect the electron gain enthalpy, and nuclear charge, and how electron configuration will affect the electron gain enthalpy.
Sir, negative means energy is absorbed, sir.
Release, na?
Positive means energy is released, sir.
Positive means energy absorbed.
Okay, sir. Negative means energy released. From
Uh,
left to right, more energy will be released, sir.
yes, and from top to bottom, less
Less
amount of
sir.
energy will become released. Okay. This we have discussed. And now let me solve a simple question on that. Mm. Solve this question. Let's try. The electron gain enthalpy of chlorine is minus 349 kilojoules per mole. How much energy released when 3.55 grams of chlorine is completely converted into Cl minus ions. Try to solve this. Let me see how many members can solve this. Done. Done, students. Okay, let me try this. I think you have tried. Let me show. Now, what happened? Generally, when chlorine gas by gaining one electron, it will form Cl minus gas. So this is what in this one energy released will be minus 349 kilojoules per mole. That means what we can say, when we are taking 1 mole of chlorine. Okay, when we are taking 1 mole of chlorine, so to gain electron, it will have minus 349 kilojoules per mole. And we know no, 1 mole of chlorine means how many grams it is? One chlorine, 1 mole of any substance weight will also equal to its gram molecular weight. So that what we can say, 1 mole of chlorine means what we can say it is 35.5 grams of chlorine. To convert into Cl minus, we need energy is minus 349 point minus 349 kilojoules. Now what he's asking, so for 3.55 grams of chlorine to convert into Cl minus, the energy how much required? So simple cross multiplication. How much we will get? 3.49 or 34.9? 34.9 we will get.
Yes, sir. 34.9.
3.9 into 3.55
Sir, 35.5 is chlorine's what, sir?
molar mass na. Molar mass no, because molar mass of any chlorine is what 35.5 only no.
Sir, how we got this formula, sir?
Huh?
This formula.
Nothing formula na. If you have simple method, if one pen cost is the unitary method I am applying. One pen
Oh,
cost
okay,
is
sir.
10 rupees. Then what is the 10 pence cost? So I am saying that 35 grams of chlorine to
Yes.
convert into Cl minus, you need this much of energy. What is 3.55 grams of chlorine? How much energy you need? That only simple.
34.9 kilojoules is released.
Uh, okay, na?
Yes.
Next one is next parameter. Let me solve one more question. Let me check who is going to answer. Where configuration of neon core 3s to 3p3. Second one, neon core 3s to 3p4.
Sir, neon core means plus 10, na, sir?
Yes. Next, neon core 3s to 3p5. The question is, which of the element has which of the element has most negative electron enthalpy? Hmm. What is the answer?
Sir, I think neon core 3s to 3p5 is more negative, sir.
Why?
Because it has more electrons, no, sir, then the more negativity.
It is having more protons, so that easily it will get attract. So if it is getting easily means, simply what we can say, neon is what? Neon 3s to 3p3 means what is the configuration, Anna? Which element it is? Which element? 3s to
Sir,
3p3 plus
3
10.
plus 10.
13 means what is the atomic number?
sir, silicon,
Phosphorus, no.
15 phosphorus, sir.
Uh, phosphorus or aluminum?
Phosphorus only, sir.
Uh, 3s to 3p2, no? Hello?
Yes, sir.
Mm. 3s to 3p3 means what we can say? It is total 15 electrons, right? So phosphorus only, right? And neon 3s to 3p4. Which one?
17, sir.
Sulfur, sir, sulfur.
16, no? Sorry,
Sulfur,
here I
Yes,
have
sir.
sir.
written 13, I have written, sorry. 15. So that is
Yes, sir.
sulfur. And neon core 3s to 3p5 means 17 chlorine atom, no? And we know no phosphorus, sulfur, chlorine belongs to same period only.
Yes, sir.
In period from left to right, what will happen?
In negativity will increase, sir.
Morning.
Size, electron gain enthalpy will become like this only, no?
Size will decrease, sir.
Size will decreases and electron gain enthalpy will be increases. That means it will become more and more negative. So we know as in periods, from left to right, more negative energy released. So neon core 3s to 3p5 has highest negative value.
Sir, how can we know that a particular element has more protons, sir?
1 second. What you are asking? Tell me.
You told that for chlorine will phosphorus will have more protons, no, sir.
Phosphorus or chlorine?
Chlorine, sir, chlorine.
Hmm. So generally, greater the number of electrons, greater is the nuclear charge, no?
Yes,
Because
sir.
number of electrons and protons are same, no?
Yes, sir.
Yes or no?
Yes, sir.
The same way. Okay, na?
Okay, sir.
Next. This is about this one. Next parameter is electron gain enthalpy. This is the last topic we are discussing. Do you people know, na? As the syllabus which I had given. Do you remember? When we started this
Yes,
course,
sir.
we had given
Yes,
one
sir.
syllabus. Do you remember? In that
Yes,
one,
sir.
this topic is the last topic which we are discussing. That means periodic table is the last topic which we are discussing. Okay, along with certain other topics also there. That also we will discuss in this topic. Huh?
Like what, sir?
Valency, oxidation states. That one.
Sir, once
Yes.
can
Oh.
you, sir, once can you go to
Uh,
previous slide?
Before that, we have discussed types of bonds also, no? Like what is covalent bond, what is ionic bond, what is
Sir,
dative bond.
go to previous slide.
Do you remember
Sir,
what is VBT, what is hybridization? Do you remember or not?
Yes, sir.
Uh, so in that one, say we have discussed on covalent bond, no? So how covalent bond will be defined?
sir, covalent bond means
Sir,
atom is
atom is
shared
shared
between
between two
an electron is
molecules.
shared between two
Uh,
two atoms.
Mutual sharing and mutual contribution of
Sir.
electrons, right? So electron negativity means it is defined as tendency
Sir,
of an atom to attract the shared pair of electrons of a covalent bond towards itself. Okay, so in a covalent bond, okay, the electrons which is shared towards itself is called electronegativity. Okay, from this one, how we can calculate actually? For example, let me take let A and B having covalent bond. Okay, between A and B, we are saying that it is what covalent bond. I'm saying that. You know, no covalent bond straight away we can write. That means what we can say between A and B, the electron cloud is systematically and symmetrically arranged. Okay, this is the electron cloud which is systematically and symmetrically arranged. Okay, this is the way covalent bond is going to form. Okay, so if in this, if A is more electronegative, than B, that means what we can say, the electronegativity of A is more. That means what, the shared pair of electrons will slightly, that means what we can say, that means between A and B is there, no? So if A is more electron means the partial negative charge on this and partial positive charge will be this, like this. That means this partial charges indicates this electron cloud is slightly migrating towards A more as compared to B. Now if you observe, B side electron density is more, no? Sorry, less, no? Can you observe clearly?
That means they will attract more electrons
Yes,
of the
yes,
bond pair,
yes.
sir.
So that
Sir,
electron slightly it will attract towards. This is what we can say
sir,
electronegativity.
That means not totally, sir.
No, no, totally cannot say. It will go slightly towards itself. That's it.
Okay, sir.
sir, if
Slightly
both
towards
are
itself.
equal electronegative, sir,
The bond remains as it is only.
that means there will be no partial negative and no partial positive, sir.
Yes.
Okay,
That one we
sir,
said
I
no
have one.
non-polar covalent bond.
Okay,
Sir,
sir.
didn't understand the meaning of towards itself, sir. Attracting towards
Towards
itself.
itself means what? For example, If see here saying that A is more electronegative, no? See here electron density is symmetrically arranged, no?
Yes, sir.
In above example. Okay, because of A is more electronegative, that electrons are slightly attracted towards itself more, no? As compared to B.
To itself means to A, sir.
Ah, yes.
Okay, sir.
The atom which is having more electronegative, no, towards that it will go.
Sir,
Ah.
so generally there won't be much electrons, na, sir. Then how can it form a cloud of electrons? Sir?
Actually, this electron, one electron means it's like cloud, nana. So it's not like group, you can't say. It's like a imaginary cloud only we can.
What is it formed of, sir? Alpha particles.
Alpha particles, how we can't say alpha particles. Okay, na?
Then
Just it is
what's
like
it?
electron cloud. How we can represent, for example, one second. Let me show you in Google how electron cloud means. One second. Let me show it on this. See this. Can you able to see the blue color dotted lines?
Yes, sir.
Okay. This is nothing but electron cloud.
Okay, sir.
Okay, na?
Yes.
So that electron cloud will be, if the atom is having more electronegativity, it will slightly move towards itself. Okay. Generally, to calculate electronegativity, it is like relative term only. Electronegativity, we can use different methods. Electronegativity can be calculated by either Pauling scale or Mulliken scale. Generally, electronegativity of electronegativity of atom is calculated by using Pauling scale and Mulliken scale. Okay, Mulliken scale. In this one, Pauling scale is my most widely used. Okay, Pauling scale, in this one, what we can say, Pauling scale is most widely used. Between this, Pauling scale is Pauling scale is Pauling scale is most widely used. Okay, na? That Pauling scale is how we can see that one. See. As per Pauling scale, the electronegativity difference is, that is, electronegativity difference, we can write it as chi A minus chi B is 0.1017 into 0.1017 into under root over delta. What I will tell you what is delta. Okay, delta, and chi A minus chi B is 0.208 into under root over delta. This value should be used if bond enthalpies are given kilocalories. If bond enthalpies are given in kilocalories per mole. and this is used. Bond enthalpies are kilojoules per mole. Okay. So chi A chi B means what? Electronegativity difference. Okay, so chi A is electronegativity of A. Electronegativity of A. Okay. And chi B is electronegativity of B. Okay. Now how we can calculate delta? Okay. The delta formula is delta is EAB minus EAA
Sir, A and
EAA.
B are any atoms?
Yes. EAB whole to the power of 1 by 2. Here EAB means bond enthalpy of A and B. Okay, bond enthalpy of A and B. A means bond enthalpy of A. PA means bond enthalpy of A bond A, like that. Okay, na? And EBB means bond enthalpy of BB. BA means bond enthalpies.
So BB is not there in formula, sir.
Yes, sir. AB, sir.
Sorry. This is AB and this is BB.
Yes, sir.
Sir,
This is BB.
what is bond enthalpy, sir?
Rare bond enthalpy we have discussed now the amount of energy required to remove one atom, to break one bond. Okay, the
Lattice
amount of
energy, sir.
energy required to remove, it, to break one bond. Okay.
Okay. KCl means kilocalories, sir.
Yes, kilocalories per mole. Okay.
Yes, sir.
Now this is about the electronegativity. So likewise we can calculate the electronegativity of all elements. Generally we can calculate. Okay. Now how this electronegativity changes in periods and groups we can discuss generally. In periods from left to right, electronegativity values negativity increases in groups from top to bottom. Electronegativity decreases. Okay, this I'm writing purely based on the values only. Okay, na? Okay, and electronegativity of an element is there, no? That element is not fixed actually. For example, let me take carbon electronegativity is 2.5. Let me take like this. As per Pauling scale, the electronegativity calculated for carbon is 2.5. But at every carbon, the electronegativity will not be 2.5. Are you getting what I'm trying to say? For example, electronegativity, electronegativity of any element. Okay, let me write on that once. Hmm. Electronegativity of any element depends on the following factors. Factors. The factors first one is hybridization. We have idea about hybridization, no? Which we have discussed types of hybridization, how to
Yes, sir.
calculate hybridization.
So once we will go to previously.
Yes, generally what we can say, electronegativity order, sp negativity orders, sp hybridization is having more than sp2 hybridization than sp3. For example, let me take carbon. Generally electronegativity is what? Generally carbon electronegativity is 2.5 actually as calculated. Okay, but if I'm taking sp carbon and sp2 carbon and sp3 carbon, so that all three should have same electronegativity, right? Yes or no? Because same atom only, no? But the electronegativity atom will changes. Understood, students, what I'm trying to say? Students, can you able to understand? Somebody asked me to show previous page. Go.
Yes, sir. Done, sir.
Okay. For example, let me take an example. Now we know hybridization of these elements. What is the hybridization here? sp3, na? You forgot. And this is sp2. And of course, this is also sp2 only. And this is also sp. Now coming into this, all are having same carbon atom, no? Yes or no? Same carbon atom. So same carbon atom means what? That all atoms should have that electronegativity value of 2.5 only, no? As carbon source. But here what we can say, because of hybridization, what is the electronegativity order? Electronegativity order will be which one, Anna? sp will have more, no? So this carbon will have highest electronegativity as compared to this and this. This is the first parameter. Second parameter is oxidation state of atom. That is what we can say, greater the oxidation state of atom, less size. Greater the oxidation state of atom, greater is the electronegativity.
Sir, once can you go to the previous slide?
1 second, wait. For example, if I'm taking iron plus 3 and iron plus 2, which is having high size, iron plus 2 is greater size, no? Yes or no?
Yes, sir, because one extra electron is there, sir.
Yes.
So could you revise oxidation states, sir?
General, what we can say, greater the oxidation state, so greater is the electronegativity actually. Okay, because greater electronegativity means what? Sorry, greater oxidation state means what? Size should be less. So as size of atom is less, easily it can get attract the electron, no? Okay, so for that purpose only we are saying that oxidation state is more. That means electronegativity also be more. Okay, these are the parameters basically which affects the electronegativity.
Sir, oxidation means size, sir.
Oxidation state of atom.
Means what, sir? Oxidation state, I don't know, sir.
Oxidation state means what? Charge which is present on the atom.
Oh, okay.
Okay, na?
Yes.
Then
1 minute.
okay, and tomorrow applications of electronegativity we will show what is and how remaining parameters will affect that one. Okay, bye students, good night. Good night all of you.